We have a mesh object that reacts the sound of my voice in real time at 60 frames per second, and it's super cool and it's super fast. We are going to see how to drive any audio source as usable real-time signal in Blender. I mean up to 32 channels for the audio spectrum that goes from 0 to 5000 Hz that flow into geometry node and shader editor. We will need third-party software to get this result. It's a little tricky, but it's free, open source, cross-platform, and there is more. This method is incredibly fast and stable and lets your system maintain all the computational resources to do amazing real-time things in Blender. I'll try to stay simple and clear as possible. You can create your own real-time audio input, probably better than mine, or you can download the project that contains my node for free. But you need to know which software are involved and how to set up your own system. This is the first software we need, QLC Plus from Massimo Callegari. This software lets you create virtual console and widget and control light fixture of any kind on stage. QLC Plus will sample audio for us and send it as OSC format through the net. Where? Another software, the second we need, Maybyte's Blender NodeOSC, which is an add-on to receive this signal in Blender. This is QLC Plus. The first thing we want to set up is our input and output. In QLC, our universe. I have already set up my own that will drive the result of our sampling through this address over this port. Okay? What we want to sample? We want to sample, in this case, my MacBook Pro microphone with this sample rate, jump into Virtual Console where we can create a widget from this microphone icon. This is a built-in audio trigger which contains by default 16 channels, but you can go up to 32. We want to first of all check if everything works. So press play and activate the widget. Okay, everything seems to work fine. So move on. We actually have 32 plus 1 for the overall volume. Go to our fixture to create the dimmers to drive our bands as float values. Outside the software, we need to create one generic fixture for every channel we have created and link them together to a DMX value in this way. So now we are linking the values of these bands to the intensity of the dimmers that let us drive our signal outside of the software. It's now time for another test. Press play, activate the widget, and activate the monitor to see what's going on. Those are the float values that run through the free dimmers, the free channel that we create. Okay, you probably don't need this, but I used this app from EXLR protocol to actually understand what's going on here. As long as you monitor OSC on your door, the port that you already set up, you can see float value running through this address. That's the IP address, that's the OSC address. There are 3 of them. 0, 1, 2 for the 3 channel dimmers that we create in QLC, run float value in real time. Okay, now we are in Blender and we have already installed NodeOSC. So create a null object and call it 0, 0. By default, NodeOSC run on this port, but we need to set to 9000, and we are going to link the location of this object to one of the channels that we create in QLC. Right click on transformation, create a NodeOSC handler. which take a little bit of time. Okay, we need the address, which is this one, 0/dmx/0 for the first. The second one will be 1, then 2, and go and so on. Then we need to tell which axis of transformation we want to move. We go for the z-axis, 0, 1, 2. This is the index of the transformation. So let's take a deep breath and hope for the best. Okay, I'm driving the location for this object with the sound of my voice. How cool is that? I can see the value that run real time for the z-axis. Now I have created 3 node object 0, 0, 0, 1, 0, 2, which I link with NodeOSC handler with this parameter. This address the 0 for the first, which is the volume, then the channel 1 and channel 2. Every one of them are linked to the z-axis. Okay, let's test it. Make sure you are running your QLC and play start. Okay, now if you create the whole 32 channel and link them together, you can recreate all of these lights. You can barely see what's happening here, but will be clear soon because we are jumping in geometry node. Create a new node, drag the first of our node object and use it to scale elements, this element. Okay, using the sound of my voice, we need to amplify this signal. Okay, check, it works. Map this value from a minimum of 0.4. Okay, this is the sound of my voice driving the scale of this object. Let's see how to drive this value in shader node. We can send it out of the node from this. We actually output a vector, but I want to obtain a float. Let's check if it works and go to shader nodes, create a new shaders. We need to give a name, so call it 0, 0, 0, 0 here. Okay, I'm monitoring the shaders, the vector value through the shader nodes. So it means if I use it to drive the strength of an emission, we can easily bring the frame rate to 60 and obtain a really smooth connection with my voice. It's really fast, it works well. So amplify a little bit this value. Check if it works. Yeah. Okay, it's low, it's high for the volume. Now we are moving a single point and drive it in a simulation where will be repeat over the y-axis for a little value. Test. Now I have a super cool tail of my points repeating thanks to the simulation. Let's do something cool with this. Point to curve. Okay, here we are. Curve to mesh. We have a mesh object that reacts the sound of my voice in real time at 60 frames per second, and it's super cool and it's super fast. Real-time audio input for Blender contains the real-time audio input node and this reactive animation. Now you can use any audio source to generate stunning real-time visuals with the procedural power of Geometry Node in Blender.